Hey guys, I'm back with another question from September 2020 Basic Electronics Exam. The question is, an astable multivibrator circuit has R1, R2 and C of these values. Okay. Now what R1, R2 are here and C is here. We need to calculate frequency of oscillation and duty cycle. Okay. So what is an astable multivibrator? So it's a device which is built on a 555 timer. Okay, so there is a 555 timer like this here, right? It's a 555 timer. 555 timer has a V out here, right? And to this, what is attached is here like this. A couple of resistors like this, and a capacitor which is connected to ground. Okay, and these are all connected to VCC. Okay, this is R1, this is R2, and this is C. Okay, so what does this circuit do? It produces a series of high and low voltages like this. Okay, so this is a time. It produces signals like this, something like this. Okay, so sometimes voltage is at high, sometimes voltage is at low. Okay, and what is the frequency of this output voltage and what is the duty cycle of this output voltage is asked here, given the values of R1, R2 and C. Okay, so how do you do that? The frequency, of course, it depends on R1, R2 and C. How does it depend on R1, R2 and C? Frequency formula is 1.44 over R1 plus 2R2 into C. Okay, so this is the formula. So we know R1, R2 and C, right? So if we apply that, so 1.44 over R1 is 6.8K plus 2 into R2 is 4.7K. This is entirely multiplied by 0.1 microfarad. Okay, so what will I get? Again, I'll get 1.44 by, this is 6,800 plus this is 2 times 4.7 is 9,400 into 0.1 microfarad means 0.1 into 10 power minus 6. Okay, substitute all this in calculator. What you will get is frequency is 888.89 hertz. Okay, so if for each second there are this voltage high and low happens 888 times. Okay, almost 889 times. So this is the frequency of astable multivibrator, which is a circuit or a device built on a 555 timer, and the frequency depends on R1, R2 and C values. Okay, then what else is asked? Duty cycle. So what is duty cycle? Duty cycle is time high by total time. So in this one cycle, for how long the voltage is high, that is time high, for how long the voltage is low, that is time low. This is the total time. Total time is time high plus time low. Duty cycle is the ratio of time high by total time. So time high by total time is time high plus time low. This is into 100%. Duty cycle is given in percent. And but I don't know what is time high and time low, but I know time high and time low depends on R1, R2 and C. Okay, so there is another formula for duty cycle in terms of R1, R2 and C. It doesn't actually depend on C, it depends on R1, R2. So duty cycle is R1 plus R2 by R1 plus 2R2 into 100%. Okay, so this is the formula of duty cycle in terms of R1 and R2. So what do I get here? R1 and R2 are 6.8 and 4.7, right? That is 6.8K plus 4.7K by 6.8K plus 2 into 4.7K into 100%. So that is 6,800 plus 4,700 by 6,800 plus 9,400 into 100%. That will be duty cycle is 70.98%. So the output voltage looks something like this. So if this is one cycle, and there is a midpoint here, right? time high is 70.9.8 and time low is 29, something like that. 70, almost 71, then almost 29. So that will be something somewhere here. So for this duration of the cycle, the voltage is high, and for this duration of cycle, the voltage is low. Okay, this is high, this is low. So for these values of R1, R2 and C, this is a one cycle of the output. Okay, and this happens 888.89 times, and the duty cycle is almost 71%. Okay, let's see another question. If this video helped you and if you want to learn more, check out our full basic electrical course. The link is in the description. Also, like this video and share it with your classmates, and subscribe to the channel and press the bell icon to keep learning.